Cool, but why is our next talk by John of Italian origin, if I recall correctly.
Hello.
Hi, John.
How are you?
Oh, thank you. Lovely. It has been a great day. Tiring, but generally a great day. I wasn't expecting it to go so smoothly after the first few hiccups in the morning. But good thing that everything is working much better right now. How are you?
I'm good. Yeah, I've tried to like make the light in here be reasonable. This is my first time doing a remote conference, but I'm excited.
Same. That's where part of the excitement and stress is coming from. It's like, what can go wrong today? Thank you so much for joining us. For our attendees, this is going to be a live talk. I think. Tell me that all of you from the chat, you're hearing the sounds. Cool, Slobodan. I'm so sorry, but the issue is yours. Well, then let's start.
Great. Thank you.
Thank you.
I assume you can all see my screen at this point. So if you're like a lot of people, when you're first learning Ruby, you're going to go through a few stages. So let's see if these sound familiar. You're going to start out skeptical. Maybe you've heard that Ruby is slow, and all of your friends say that it can't be used for writing real software. They're going to send you some links to articles about sites that were built in Ruby and had to move off because of scaling problems. You'll almost be convinced until you realize that every article that you're reading was literally written in 2008. Next, you might be confused. You maybe never seen a language that looks like this before. You're wondering, where did all the punctuation go? And wait, array iteration is just another method call? And oh God. And then you're thinking, wait a second, am I having fun programming maybe? As the language wins you over and the code starts to flow, you're naturally going to get excited as you grow more confident. Everything's an object. The standard library has so many great things. There are sensible names everywhere. Why don't all languages just use sensible names? And the community, well, you all are amazing. Now you're writing real code, things are coming together, and you're loving it. And this is about the point where some cranky senior programmer walks in the room, looks at your work and says something like, this code is not very Ruby. And it's like, what does that even mean? You may have even found yourself in this position later, saying the same old stuff to other newer Ruby developers. We just don't use that feature. They were writing Python Ruby. Or my personal favorite, and probably the one you hear most often, it's just not very idiomatic, is it? While often advice that you receive originated in a good place and with good intentions, more often than not, the person giving it doesn't have the backing of why. They're just repeating something that they heard. They can often be wrong, misguided, or have assumptions that are based on evidence that just isn't the case in modern Ruby anymore. So I'm here to say, don't be a parrot. Unless you are an actual literal parrot, and then in that case, please just continue to be a parrot. Okay, so everyone repeat after me at home, don't be a parrot. If you just repeated it, then you're not getting it yet. Today, I'm going to dig into some common things that are seen as bad Ruby. I'm going to talk about why, and I'm going to go through some code examples to demonstrate. I don't need you not to say, we don't use that anymore. I just need you to say, we don't use that because. The things that I want you to take away here are a set of practical tools as a starting point and a mindset that you can use to become a better developer and a better mentor. So before we get too deep into this, I should introduce myself. My name is John Crepezzi, and my internet handle pretty much everywhere is @cjohnrun. I live in New Jersey in the United States with my family. Anche io sono un cittadino italiano, nonostante il mio italiano imperfetto. I love Italy, and I wish more than nearly anything that this pandemic was over and that I could be over there with you in person. A few years ago, my wife and I were over at a bar in Milan, and we overheard an American couple. It was a cocktail bar, and our cocktails came out. We heard this couple at the next table. They left, and they said, "No one drinks Campari in Italy anymore." Well, as soon as I'm able to, I will be back to disprove this statement. I'm a staff software engineer at GitHub. I've been at GitHub for a bit over 3 years. And I've worked on a ton of really fun features there with some amazing people, including Eileen and Aaron. I've been working in Ruby professionally since 2009. I've worked on a bunch of open source software. I've worked at Patch, Genius, and Square, and I've started a few startups along the way. This is all just to say that I've definitely put in my 10,000 hours at this point, but I don't consider myself an expert. And that's primarily because I think that experts are bullshit. There's so much to know about software, even a relatively minor topic like Ruby, and it's constantly evolving. So the only thing that you should trust is known, and even then only temporarily, is your own experience. So let's get back to that. And maybe at this point, you're thinking, so if we shouldn't trust what people tell us and we don't want to be parrots, then maybe we shouldn't trust you and we shouldn't listen to you. And it's like, first off, rude. And you know what? No, you shouldn't trust me. And just for that, I'm going to sneak one lie into this presentation, and you get to try to spot it. So just a fair warning up front here. I'm about to show and talk about a ton of code. It's going to be fast, but I'll share a link to all of my examples at the end of this presentation. And I encourage you to check them out locally, experiment with them, and then come to your own conclusions. So let's get started. And I'm going to start with for loops. This is one of the most common ones for developers coming from other languages new to Ruby. For loops provide a simple way to iterate over any enumerable. You can even, in the bottom example, you can see, do a handy destructuring with for, similar to how you'd use each on a two-dimensional array. But we're told not to use them. We're told they're not Ruby. Cool, but why? Let's start with the reason that you maybe hear from people. And that's that when you're using each, you'll be creating a new scope. You can see here inside of each that I'm making a new variable called new var. And then outside of the block, if I try to access it, I no longer have access to that variable. So I get a raise name error. Contrast that with using for. When we define new var inside of a for loop, it isn't created inside of a new scope. These variables stick around and they continue to be accessible outside of the for loop. And if you're like me, right now you might be thinking, who cares? That seems like a pretty weak reason to choose to not use something. After all, if also doesn't create a new scope, as you can see here. Other keywords that we use pretty often, like while, until, and case, they work the same way. In fact, you might be surprised to see that due to the way that the Ruby parser works, you don't even need to use these variables in order for them to be defined. But that's a topic probably for another day. Yes, despite these other keywords working the way they do, we don't hear many people proposing something crazy like maybe implementing if using blocks. Although looking at it now, I kind of don't hate it. Let's learn a new tool real quick. This is Benchmark. It's part of the Ruby standard library, and it gives us a quick way to compare multiple implementations of something. We require a benchmark, and then we can write multiple versions to see how they perform. And in return, we're going to get out this list of the versions compared to each other on several different dimensions. For our purposes today, the one that's really easiest to conceptualize is the last one. It's the real category. This one measures what you kind of expect. It's wall time. It's how much time that version actually took to run on a real clock. If we run a simple benchmark on that funny if block version that I showed previously, we're going to see that the runtime of this block form is about 2 times slower than the keyword version. So maybe that's a reason not to use these block versions. And then maybe you see where I'm headed next. If is faster than the if block predicate version, it would stand to reason that for should probably be faster than each. Here I've written 6 separate implementations of a basic for loop. Let's see how they do against each other. First, and not too surprisingly, while and until are nearly identical. Also not very surprising based on the performance of times and up to are very similar. Even each is very similar to times and up to, and that makes sense. They're all methods that make a call and then yield to a block. But what about for? Well, here we can see that each in this benchmark is actually faster than for. And that's pretty weird, right? And actually, if we don't just include the iteration inside of the loop, but run the loops multiple times in the benchmark, we'll see the numbers diverge even more. How can this be? This is the point where we should all be happy that Ruby is open source. We don't have to wonder because we can go look at the source code. So we go deep 6,500 lines down into compile.c, and this is the C code that handles implementing for. Now, I don't need you to know C, but if we look right here, we can see that Ruby's implementation of for literally is sending to each. For is implemented in terms of each, just like our if predicate method was implemented in terms of the keyword if. So now the evidence is stacking up quite a bit. You shouldn't use for, or you shouldn't avoid for because its syntax is confusing or because it's ugly or because it's not Ruby, but you might choose to avoid it because it's an unhelpful abstraction on top of a more flexible method called each. I realize the technical content here is pretty dense, so I'm going to mix in some photos of my favorite European Ruby conferences from last year. This one was in February of last year. This was Ruby on Ice in Tegernsee, Germany. We had the opportunity to stay at what I think is probably the nicest hotel that I've ever been in. It was directly on the lake, right there. And afterward, I took a week off, which is something I pretty much never do. And my wife and I, we went over to Salzburg for a week. This was a really nice trip, and going outside was awesome. So now let's look at something completely different. Method missing is a feature that people love to hate. Often embraced by people who like to feel clever, method missing is both a blessing and a curse. It's also typically seen as a code smell, but why? Here's the default implementation of method missing that exists on basic object. Again, don't worry too much about the specifics, but the Ruby equivalent is essentially raise name error. And because the Ruby gods have exposed this method on basic object, that means subclasses can override it and supply custom behavior for what happens when a method isn't defined. So here's a simple illustration. In this example, we've created a custom implementation of method missing that lets you call any method and then returns the name of the method you've called backwards as a string. To make a slightly more useful example, here's a quick and dirty way that we could abuse method missing to take a hash and make its members accessible via method calls. This is a very dumbed down version of something like the Hashi library maybe that you've used in the past. The thing everyone knows for sure, and what probably has a few of you squirming in your seats right now, is that if you define method missing, you also need to define respond to. But why? The reason you need to define respond to is because if you don't, anything trying to determine if a certain method exists is going to receive the wrong answer. Does .hash respond to A? No, it doesn't. But if you define a custom respond to, well, now it will. So now everything at this point is perfect. Respond to returns the right thing. We can call the method. We can even look up oh, damn it. The thing is that since the method was never explicitly defined, Ruby doesn't know how to find it. Luckily, Ruby provides a way to fix this. Instead of defining respond to, we can define respond to missing. And now our method appears correctly. Of course, things like public methods still won't include these methods, but that's understandable. Is something maybe tingling in your brain though? Why did we need to define a custom respond to missing? Why wasn't defining respond to enough to get method to behave correctly? And more importantly, what does the fact that it wasn't enough to define just respond to imply about the behaviors of these methods? Let's bring our benchmarking tool back out. Here we're comparing calling respond to on a real defined method versus calling respond to asking about a method that's only defined through method missing. And no surprise, the real method call is slightly faster. Not a very convincing reason to not use method missing though. It's when actually calling the method that the true difference is going to start showing itself. Now we're seeing more of a difference in call times, and it should be pretty clear why. 2s in the first example can find the method and call it directly. A on the bottom goes through a level of indirection to get to the right place. So let's just draw that out to really illustrate the point. On the left side, we have a regular method call. We call the method, we look it up, we find it, and we call it. On the right side, though, when we call a method, we have to look it up, and now it's missing. And now instead of being able to call method missing, we have to look up method missing. And then when we find that, we can call it. It's this extra step that makes method missing definitions a little bit slower. Okay, so we've settled on maybe one reason to choose to not use method missing unless you really need to. And that's because it's pound for pound slower than a defined method to actually call. But that's probably not enough of a reason. There's another problem though. Let's take a look at what happens if there's a failure somewhere inside of a method missing call. You can see down here in the bottom error backtrace that we've called this method apple. It's errored, but the backtrace contains no mention of the method that we've called. That's going to be pretty confusing to try to debug. Now, can you fix it? Sure. But we're getting closer to the primary reason that using method missing is typically avoided. And that's because the method missing implementation is super complicated, bordering on impossible to implement correctly, and in a way that doesn't hinder developer ergonomics or cause significant performance overheads. Rails, for example, goes to intense lengths to give developers a good version of method missing that feels natural. Wondering how they do that? Here it is. You can see that when you call a dynamic matcher in Rails, it literally defines the method and then immediately calls it. This keeps the backtrace clean and avoids the performance penalty on subsequent calls that would typically come with method missing. So is this a good option for developers? How do we define methods in Ruby? Are there any drawbacks here? Well, you probably saw where this was headed. We're going to dig into define method and we'll figure out what the deal is in there. But first, it'd be crazy not to talk about last year's Uruko conference. This was June of 2019. And I mean, come on, it was on a giant ship. The right side here was a brewery nearby that we spent a lot of time at. It was called Caps. And yeah, I mean, just like going outside is really nice. Okay, back to define method. Imagine you want to create a class with two methods that are entirely identical except for their name. Define method is a way to define their behavior quickly and with less repetition. You can see here that I'm iterating through an array of two symbols, foo and bar. And for each, I'm defining a method that just returns the same symbol. It's tempting, but you're often going to get pushback trying to put code like this into production. Cool, but why? For all meaningful intents, these methods are just like all the other methods that you might define. Calling respond to on an instance of something returns true. Calling the method works fine. Looking up the method works fine. Even trying to list the methods will contain the correct symbol. They behave just like methods. So we should be able to compare these two side by side, and we're pretty much expecting them to perform the same, but they don't. Okay, so defined methods are slower to call. Why? Clearly, this isn't just a method. If we drop a pry debugger into the middle of all of this, we can get a hint of what's going on. We look up the definition of foo, and we get back the define method block instead of receiving back the actual method definition. This is kind of hinting to us that maybe the thing we're defining, it isn't a method after all. Resorting to some old tricks here, let's go to the relevant part of the Ruby source code for define method. Okay. So define method is actually pretty complicated because it can take in more than just blocks. So how about we just like zoom in here on the relevant piece. In this part of the definition, we can see how define method actually works. It creates a proc copy of the body that was passed in, turns it into a lambda, and then it defines the Ruby method that you're defining in terms of the proc that it was just created. Here's a roughly equivalent piece of Ruby code that should help illustrate what's going on and why methods created via defined method are slower than normal methods to call. They're slower because instead of calling the method directly, you'll always be calling what essentially amounts to an instance-evaled copy of the original block. But it doesn't stop there. There's another issue with our typical uses of defined method that's problematic. So I'm going to break my format a little bit here to look at another class of problem that might not be super obvious, but one that you should be keeping in mind when using defined method, and in fact, as we'll see, all other methods that take a block. When you're using something like defined method when setting up a class, inside of the block, you'll have access to any objects that are currently in scope. You can use them inside of your block. Here, I'm using a local variable called greeting inside of a defined method called greet. Unfortunately, that comes at a cost. You see, Ruby uses reference counting to keep track of garbage collection. And normally that works really well, and you don't have to think about it too much. But when you introduce a block like the one for defined method when creating a class, since Ruby can't tell what things you might reference inside the block, it needs to keep all of them accessible. That means that it can't free any of the objects that could be reached from inside of that block until the block is freed. In this example here, of course we can all agree that greeting doesn't get garbage collected, but it might be surprising to hear that neither will other var, despite the fact that it's literally never used. Just saying that is all well and good, but you probably expect me to prove it, and that's exactly what I'm going to do. Ruby comes with a useful library called object space. Just like benchmark, we have to require it in to get access to these methods, which, by the way, should only ever be used in development. I encourage you all to take a full tour of this module yourself, but just to get you started, I'm going to shout out some of my favorites. So count object size will give you essentially a hashback that has all of the types for Ruby and how many bytes they're currently taking. Mem size of all will take a class in and give you back the consuming memory total of all the living objects of that class type. And each object will actually give you, you put in a class and you can pass a block that will receive each of the current alive objects of a given class. So given those tools, it should be pretty straightforward to put together an experiment here. This is a quick and dirty method that just runs garbage collection, counts the total memory size of a certain class, yields to some code, and then reports back the difference after the block is over, after running garbage collection. So essentially, by wrapping code in this block, we're able to see how many bytes of memory were created for a given class inside of the block, but then not able to be released. If we run this and we create a string inside, but we don't reference it anywhere, we can see what we expect, 0 bytes. That means that the string str was able to be garbage collected before our block was over. Now we make a quick modification. So what we've done is we've defined string to be scoped outside of the block. And we can see what we expect here again. The string doesn't get garbage collected. We get back 40 bytes of unreleased string. It looks like everything is working with our experiment, so let's jump back to where we were before. We're going to wrap our greeter class definition in our test method. And you're going to see exactly what I was saying before. Ouch, 10,081 bytes of a string that won't be garbage collected, despite the fact that it's not being used. Now, for a more meaningful illustration, imagine that we're loading a bunch of data in order to populate a list. We open a file, we pull some data out of it, and we put it into a constant called band users. Later on in the class, we use define method. Now, it's very obvious that band users is not going to be garbage collected. But here, by mistake, we've actually taken away Ruby's ability to garbage collect, and in this case, even close the file pointer for the file that referenced by band user file. As a result, we've retained 8,424 bytes of unreleased file. And just to be really clear, this isn't just a problem at the class level. It's anywhere that a block is passed to a method that holds onto a reference to the block. So in this example, we're calling parse, and we're calling add callback, And the file handler defined by file will not be released until the actual user object itself is garbage collected. If you nil out these references, you're going to let Ruby's garbage collector continue to do its amazing job. And this is how you have to fix this issue if it's something that you're encountering in your application. So define method isn't free. And that doesn't mean don't use it, but it does mean that you're going to pay a constant cost on every call to a method that was created via define method, and that you have to be careful of what objects you're unintentionally retaining. But is there a way to avoid that? There is, but you might not like it. Class eval has the benefit of creating real methods, and due to the way that they're evaluated, they can't hold on to any closure context from the surrounding scope. So in this case, other var would be garbage collected as soon as food is finished being declared and garbage collection runs. So just to be really exhaustive here, here's a benchmark showing the methods created via class eval are 100% identical to real Ruby methods. They have a higher upfront cost to be created, but they incurred no extra cost per method call. If you've ever seen a bunch of dynamic code class evaled for a hot code path, this is why. In fact, Rails define method that I showed you earlier, it uses class eval to define dynamic matchers. It's tempting to overuse Ruby's metaprogramming features. It can result in less code and, more importantly, less duplication. If you really need to know what you're doing, and you need to be aware of the potential trade-offs that you're making. On the flip side, every path doesn't need to be fully optimized. Things like class eval definitely make code harder to reason about. They make it harder to search and ultimately harder to maintain. You need to make the choice that's appropriate for your use case. So, okay, you caught me. These are not from a Ruby conference. This is just our summer vacation last year. This is at Vieste down in Puglia. The water is just so clear. These are my daughters, and this daughter's name, her name is Ruby. Okay, let's go for a lightning round. I'm not going to go all the way on these. I'm just going to start you off with some things to think about. Use symbols over strings whenever reasonable. Cool, but why? Historically, the reasoning is that strings are mutable. So they're new objects every time that you create them. You can see here that if I create two strings and I compare the object IDs, they'll be different. Symbols are immutable. And due to that, they always point at the same objects. Thus, they cause less memory churn. You can see here I'm creating two symbols with the same value, and the object IDs are the same. That's the reason you're going to hear from people. But a lot of these once compelling reasons are less compelling now that frozen strings exist. And by the way, do your own benchmark, but frozen strings are just as fast as symbols when it comes to lookup. Still, many developers choose to use symbols as a signaling device of immutability. And standardizing on them is, especially in control flow circumstances, not only avoids unnecessary markup, but it reduces confusion about what type of object you're handling. Did you ever get an object and say like, these are not equal, but I expect them to, and it turns out that you are holding onto a string when actually you're comparing to a symbol. Also, somewhat obscure markup tip on the bottom here, you can create symbols with interpolated values like this. Interpolation is not a reason to have to use strings. The next one is always use adder. Cool, but why? You'll often hear to use things like adder reader, adder writer, and adder accessible. I say use whatever version feels most natural for your use case. But just to really set your brain off a little bit, and get your mind spinning, I will mention that the adder definitions are slightly faster. So why don't you go find out why? You'll also hear don't use keywords like and or. Oh wait, that's confusing to say. Don't use keywords and or. Okay, never mind. Cool, but why? Okay, so a regular double ampersand gives you behaves like you're used to in all programming languages. the entire right-hand side of the statement here is evaluated before assigning to foo, and foo becomes 3. And the keyword and is a lower precedence version of double ampersand. So the behavior is pretty wildly different. For illustration, you can think of the keyword version here essentially as first evaluating foo equals 2 and then ending with 3. And even that isn't quite right, because the and version returns 2 and the double ampersand version returns 3. This is why people avoid using it. It's said the same way out loud, it behaves very differently, and it can introduce very, very subtle bugs. This one I pretty much agree with, just don't use them. Another one you're going to hear pretty often is don't write comments. Cool, but why? You know what, actually, I take that back. Not cool. Write comments, please write them, and if you want to, and tell people that tell you not to find something else to worry about. Phew, okay. We are nearing the end here. And if I can have you only take away one thing from this talk, it's that hashes should not have spaces inside of them. I mean, really, just think about it. But if I can have you take 2 things away from this talk, then the second one would be that questioning accepted wisdom is the fastest path to growing as a developer. Reading the headline of an article shouldn't be enough to convince you of something. In fact, even reading the full article shouldn't be sufficient. We're engineers, and the way that we learn is through experimentation. Through this, you're going to grow as a developer, and when you do, you're going to help the other people around you do the same. And I hope that in this talk, I've given you some tools to help on that journey and pointed you in some new directions to explore. Thank you for having me, and enjoy the rest of the conference. Hello. You're going to help.
I was waiting for the and you're live that didn't come. So this has been great. Literally super fun. If you look at the chat afterwards, everybody has had a ton of fun. Thank you so much.
Great to hear.
For making us experience again a little bit of that joy in finding why. I don't see many questions beside one that is like, which was the lie? But that's not something you're supposed to answer, to my understanding. So.
Although I do want to introduce the possibility that the lie was that I was going to tell a lie. So just like, let your mind. Yeah.
Let's see if someone else has questions. Amazing performance I'm reading. So did a good job. We have a bit of delay between the streaming and what is shown on the... There it is, the question I was waiting for. Should we prescribe this doc when writing a Rubocop config? I think it's a bit of trolling. But yeah, no, that makes a lot of sense. I think the 2 things that stuck with me were the ones about the symbols and the and or thing. When I was in my previous company, we had, I swear to God, it was like a meeting with, there were 20 developers in a room with our team lead. And the topic of the day was, should we go for single quotes or double quotes? And mind blowing.
Yeah.
But yeah, so that was also remembering that conversation, because in the end, there was no real reason for really sticking with either one or the other all the time. That brought me to look a little bit deeper into this and or conundrum.
early in my career, I was early in my Ruby experience, I was very into single quotes as a way to indicate that there was no interpolation in the string. But do you really need that hint as a way to do things? Like you can pretty much see. And then I remember back then someone publishing almost jokingly a benchmark about single quotes versus double quotes, just trying to point out how ridiculous the argument was. At GitHub, we use double quotes for everything just as a matter of consistency. And it honestly kind of annoys me a little bit, but it's not worth a fight.
Yeah, definitely. That is the other thing. Like if we're talking about performance at this level, again, probably the most costly part of the whole application, it's us. So just short circuit everything else and go for one because it's not worth the fight. Definitely. There is a question from Aaron. If you use define method with a lambda, does that make it a blocking method? Yeah, it was very valuable meeting, Antonio. Totally agree. Back and forth. People are asking is if cool but why is already a meme. We can make one.
I would like that. That sounds great.
Half the keystroke, twice the speed. Good point. You see, we can keep debating about this for the rest of the day, I think. Anyways, John, it has been great to have you here. I didn't expect to laugh so much and to learn actually so much after 10 years of Ruby development.